Good afternoon. Today I'm going to show you how to convert a large complex ODB++ file into GDS2 so it can be run through a rasterizer. The file that we've provided is a large panel. You can see by looking at the steps that it has quite a number of steps, and it's hierarchical. You'll have PC boards, you'll have an array, then you'll have some strips, and finally you'll have a panel. So this is a view of the panel. We're not showing the internal data because it takes a long time to draw it in this program, but this is the size of the panel. It's about 500 by 600 millimeters. Artworks converter is called SFGEN, and you start by selecting the file that you want to process, and then the file will be scanned by the program. When the scan is complete, it reports it's okay. And now you'll see a list of steps, and you'll see a list of layers. We're primarily interested in board layers that are signals, so we're going to do the comp layer because it's a very complex layer. That's the top layer. As far as selecting the output file, we can go to any directory we want, and we're going to create a file called comp.sf. As far as settings, there are a number of settings. We're going to use 4 threads because this computer has 4 CPUs. Arc resolution of 45 degrees, a chord error, which is really the maximum error between the arc and the approximation of half a micron. No transformations, but you can see that there's a large number of transformations available. No text annotation and no distortion correction. So to run this, we just press convert. Now there'll be some processing. First it'll process all of the symbols that it finds. These are like Gerber flashes. Then it'll start generating the layer. Now one of the things it does is it looks for a hierarchy. Of course it uses the step hierarchy already found in the ODB file, but then it checks to make sure that there's not data coming in from other levels of the hierarchy that might disrupt the repetition. You can see the GDS2 file. If we zoom in, you can see the individual pieces. And one thing you'll like is that the data has been completely contourized and cleaned, and this usually helps speed up the rasterizer since there isn't a lot of redundant polygons on top of polygons. It's all been removed and cleaned up.